as you've been working in this domain for a very, very long time, what are the most pressing challenges that you face in your everyday job as a deep learning software engineer?
I think the biggest challenge that I face in my everyday job as a deep learning software engineer is getting unstable code to work. So, I work in very close to the hardware, and I work on the system before it's frozen. So this is when the hardware is being designed. You want to design the hardware correctly, and the only way to do that is to run the hardware, run real workloads on the hardware. But since the hardware isn't ready yet, you don't have the option of running on the hardware. It doesn't even exist. And so what you have to do is you have to use various simulators that are designed to mimic how the hardware will run. And usually there's a range of them, with increasing fidelity. And as a rule, because the hardware is not yet ready, and because the specifications have not yet been frozen, these simulators rarely ever run completely flawlessly. And so you always have to go in and sort of figure out, okay, what's going wrong? And then you have to, contact the people who work on the simulator and say, hey, I think, this is not quite how it should be. And then they say, yeah, yeah, we need to fix that. And then you work together with them to find, a fix and get it in the emulator so that it can be run past that point. So that happens a fair bit.
What's one advice that you have for deep learning software engineering aspirants to become successful in their career?
Learn, learn, learn. It's a very rapidly changing field. What used to be true last year is no longer true this year. What used to be true 2 years ago, people have already forgotten. You have to keep up with the knowledge as it changes. You have to keep up. You have to be willing to keep up with the knowledge as it changes. It's actually staggering just how quickly the field is evolving. And keep your mind open to other possibilities. So as an example of this, it turns out that artificial neural networks don't work the way our brain does. Even though people say, oh, it's like the human mind and things like that. The truth is that there's a fundamental difference between how the neurons in our brain work and how the neurons in an artificial neural network work. And there's this whole area of research called spiking neural networks that try to create computer algorithms that more closely mimic how the brain works. The problem there is that the field is very immature. It has yet to hit the point where a lot of the technology can be commercialized, and so it's still in very nascent stages. Now, if you think to yourself, okay, I'll become a deep learning software engineer and I'll learn about convolutional neural nets or recurrent neural nets or whatever, and then 2 years later, when these spiking neural networks become viable commercially, your body of knowledge will be completely outdated in a few hours, as soon as the paper comes out that announces that they can do something useful with spiking neural networks. So you have to be willing to keep up, and you have to be willing to keep enriching yourself, your knowledge and your skills.